The following is a reflex arc showing the path of a spinal reflex. I wanted to walk through the main principles of a reflex arc. Now you should note that this is a spinal reflex that is occurring in the somatic nervous system. When we talk about the autonomic nervous system, there are going to be two motor neurons originating from the lateral gray horn. Now, this is not shown here, but the same principles still apply. However, the effectors will change. Now, let's first focus on the somatic reflex arc. Notice in the upper right hand corner a pin going into the skin. This is activating nociceptors. Nociceptors increase the influx of cations, depolarizing the cell. This depolarization results in the production of an action potential, which travels along the axon, right, from node to node. That action potential is traveling across the myelin sheaths. Eventually, this action potential passes through the dorsal root ganglion, which are clusters of cell bodies, or gray matter. This nerve impulse will finally terminate at within the posterior gray horn or dorsal horn. This is the gray matter or integration center of the spinal cord segment. The neurotransmitters will then be released into the synaptic cleft, where they can bind to receptors on the interneuron. The nerve impulse creates a graded potential in the cell body of the interneuron. That graded potential, or depolarization, results in the production of an action potential at the axon of Hillock, located the superior portion of the axon. The action potential travels down the unmyelinated axon. I'm going to repeat that. The graded potential forms in the cell body of the interneuron. Then it creates an action potential at the axon of Hillock and travels down an unmyelinated interneuron. It's unmyelinated because it's in the gray matter or integration center of the spinal cord segment. Now, as that action potential reaches the axon terminal of the interneuron, again, neurotransmitters are released into the synaptic cleft. They bind to receptors, and this results in the production of a graded potential in the motor neuron cell body. Cell body of the motor neuron. This is in the anterior gray horn. The graded potential then forms an action potential at the axon of Hillock at the start of the axon, and then again, nerve impulse travels along the myelinated axon of the motor neuron. Eventually, it reaches the axon terminals located at the effector. In this case, we're talking about skeletal muscle. Now, it's an important point here that I want to make. Now, this is a somatic reflex. So when we talk about somatic nervous system, we're talking about our senses and the skeletal muscle and skin. When we talk about the autonomic nervous system, this nervous system involved in involuntary controls, such as cardiac myocyte contraction and peristalsis of the GI tract, there's a couple differences. First, notice that in this diagram, the cell body of the motor neuron originates in the anterior gray horn. But in the autonomic nervous system, the cell body of the preganglionic motor neuron originates in the lateral gray horn. This brings me to the second difference. This diagram illustrates only one motor neuron, but in the autonomic nervous system there are two motor neurons, a preganglionic motor neuron and a postganglionic motor neuron. Remember that the ganglion of the autonomic nervous system are located outside of the central nervous system, whether it be close to the spinal cord or close to the targets, such as the terminal ganglion. So the preganglionic motor neuron cell body originates in the lateral gray horn of the gray matter or integration center of the spinal cord segment. It then forms a synapse with the ganglion, which is composed of the postganglionic motor neuron, which eventually reaches effectors of the autonomic nervous system, including smooth muscle, cardiac muscle, and glands.